Hello and welcome to Business Calculus Income Distribution. The United States Census Bureau compiles and analyzes data concerned with the distribution of income among families in the United States. In 2011, the Bureau reported that the lowest 20% of families received 3% of all family income, while the top 20% received 51% of that income. We will use a tool called a Lorenz curve and the area between two curves to measure income distribution. The Lorenz curve is an approximating function, and in this case describes income distribution. We want to measure the space between absolute equality, given by the function f of x equals x, and the actual distribution of income. If every family had an equal income distribution would look like the identity function f of x equals x, spread evenly so the percentage of the population corresponds directly to the percentage of the income they account for. If only one person or family had all of the income, then the distribution will be g of x equals 0. We call this situation absolute inequality. This is more clearly demonstrated by the following image. Here we have the family income distribution from the 2011 census. As you see, there are several data points along which we see the relative percentage of the population and how much of the total percentage of the income they account for. So, as we mentioned before, 20% of families account for just 3% of the total income. If we look at the bottom 40% of families, we see that we get up to 11% of the total income, and so on according to the chart. At 80% of the population, we have only accounted for 49% of the total income available in the United States. So that means that the top 20% holds the 51% of the income that we mentioned from the last slide. So these percentages are of course listed as numbers between 0 and 1, so 0.4 corresponds to 40%, and so on. In order to give us a tool to measure the green space that we saw in the last slide, we have something called the Gini index of income concentration. We want to measure the difference between absolute equality and absolute inequality with this index. So, if we have y equals f of x as the income distribution, and it is represented by a Lorenz curve, we have that the Gini index looks like the following: 2 times the definite integral from 0 to 1 of x minus f of x dx. This index is always between 0, which represents absolute equality, and 1, which represents absolute inequality. At 0, all of the families are going to have an equal income, and at 1, one family has all of the possible income. Let's look at an example to demonstrate how this works. The Lorenz curve for the distribution of income in some country in 2013 is given by f of x equals x to the 2.6 power. Economists predict that the Lorenz curve for the country in the year 2025 will be given by g of x equals x to the 1.8 power. We want to find the Gini index for each function and interpret the results. So here is our first income distribution curve. We see that f of x is given by x to the 2.6 power, and the Gini index is given to us as the definite integral from 0 to 1 of x minus f of x dx. So, don't forget the 2 out front, sorry about that. And we want to calculate this definite integral. So we have 2 times x squared over 2, which is the antiderivative of x, minus x to the 3.6 power divided by 3.6, evaluated on the interval from 0 to 1. So clearly when I plug 0 in, I'm going to get 0, so we're not going to worry about writing that down. So we have 2 times 1 squared over 2 minus 1 to the 3.6 power divided by 3.6. And then with the help of a calculator, we see that this is approximately equal to 0.444. All right, very straightforward calculation. All right, here's the setup for our second income distribution. We want to calculate our index, and so we have the definite 2 times the definite integral from 0 to 1 of x minus g of x dx. And we have some very simple antiderivatives to calculate. More power rule. Antiderivative of x is x squared over 2. We subtract from that x to the 2.8 power divided by 2.8. And we're going to evaluate those from 0 to 1. Just like last time, if we plug in 0, we're going to get 0. So we will skip writing that down. And we're left with 1 squared divided by 2 minus 1 to the 2.8 power divided by 2.8. And 1 to both of these powers is just 1, so we're left with 1/2 minus 1 over 2.8. Again, appealing to our calculator, we're going to get that the index here is 0.286, rounded to the 3rd decimal place. And we compare this result to our previous value. Now, for the 2013 estimate, we see that the income distribution is 0.444 approximately, and for the 2025 estimate, we see that our income distribution index is given by 0.286. Because the second value is closer to 0, that means that our income distribution is closer to equality. So our conclusion is, if the estimate holds, income will be more equal in 2025. So, again, an index closer to 0 means more equal distribution of income. All right, now it's your turn to do an example. What is the Gini index of a country whose income distribution is modeled by g of x equals x to the 3.8 power? Here are some potential answers. Please round to the 3rd decimal place. Thank you very much for listening.